Perfect. Hi. Okay. Right. So like you have to, it's a complex navigation problem. On top of that, again, sure, like when you're walking, sometimes you run into issues, but as soon as you're gonna run into a problem, like you can very quickly detect when something's gonna go wrong, and you can do like this very rapid negotiation. Like you look at the other person, you're like, did you realize too that we're gonna crash? And like to figure out like who's gonna get out of the way. And all of that, like that's a very complicated planning problem that requires a lot of social inference and prediction. And you're doing it kind of for free. Like while you're doing that, you might be walking with someone else and you're just like having a conversation about what happened in the other day. You're quickly getting a sense of like who here is in a rush, who's a tourist, who's tired. And on top of that, you're making all these like additional like social inferences that we think more as like social psychology of like SES and like all of these additional factors. And these are just kind of like two very tiny events and kind of like the whole space of like both common and very novel social situations that we need to deal with and that we deal with very nicely. So the kind of things that like we ultimately really want to understand is, what are the representations that allow us to do these things that only humans seem to be able to do, right? Like you can find some kind of that behavior in other animals, but not at this level of like sophistication and complexity and just kind of like real time, like amazing social tracking. We can talk more about that. So the question is like, actually, what is actually going on in your mind, right? Like when you're doing these things, or like when you're right here, like presumably there's like some kind of social representations. And what are they? We're interested in like, are there any shared principles, right? So you might say, maybe we just have evolved a kind of like a toolkit of like very specialized things, right? We need to like walk around crowds and we have something for that and we need to learn from other people and we have to do that. So you might imagine we have a collection of kind of like a lot of different social skills that allow us to do this. Or there might be some kind of like very central kind of like reasoning engine that is very flexible. And that's what allows you to do kind of like, not just perform very well in like common social problems, but also novel ones. And I'm not going to talk about this today, but a lot of the work that we do is also developmental. So we were also really interested in kind of how do we come to this point. Actually, at the end, I'm going to talk a little bit about stuff, but it's not stuff that we've done. I'm just going to speculate wildly because it's fun. Obviously, these are kind of like some of the oldest questions in cognitive science. We're not the first ones to ask. And that makes it kind of easy because there's kind of like a lot of work behind it, and there's a very promising start, right? A very dominant idea in social cognition is that what you're doing when you're interacting with someone else is you're basically kind of like building a model of their mind, right? It's called the theory of mind. It's kind of like a simplified model. Like you can't represent like the entire mind of another person. So you kind of find like a simplification that's like really good for doing inference very quickly, predictions, and kind of like making sense of the other person. It looks kind of something like this, right? So you see, people have some kind of perception, basic emotions. Then they have like these two kind of like things that you can't see, right? Other people have desires and beliefs or knowledge, and that causes their actions and then how they behave. So, and in this case, like what's really important are like these two internal nodes. Those are the mental states. Like that's what's happening inside another person's mind. So the basic idea is that what you're doing right now is you're watching me and you've instantiated like a model, something like this in your mind. And all you can see are kind of like my actions and reactions, right? Like you're seeing my body moving around and I'm making sounds. And from that, you're trying to like figure out like what is going on in my mind? Like what is it that I believe and know? And what is it that I desire? And it's like, if you manage to get those two mental states for me, then you're basically solve much of the hard problem, because now you can explain my behavior, you can run the model forward to make predictions, and you can think of like how to manipulate my mind. And of course, this is a very dominant, oh, let me hide myself. I find it, I was seeing movement of myself by the periphery. Right, so this is kind of like a very dominant framework, and it's called it's something called mind reading, right? Because they're kind of like trying to read the mind, or trying to figure out what's going on in the mental states. I mean, of course, there's like very major debates in developmental science. A lot of it's like figuring out like how well and when can we mind read. This is a big question in comparative cognition. A lot of work in computational cognitive science focused on trying to figure out how we do this. And there's a lot of work trying to apply to other domains, so trying to explain other amazing things that humans do, like moral reasoning or language. So I think there's something very right about this. Most of my work has been trying to promote this view. But what I want to claim today is two things. And basically, like, I think we're missing a lot. So the first claim is that this idea of mind reading, it's a very incomplete picture. It's kind of half the picture. We got a lot of social intelligence is mind sharing, right? So the problem is like these classical frameworks really plays the problem in a very weird way. It's kind of like there's an agent moving around and they don't care about anything. And then it's your job to just kind of like watch them and scrutinize and figure like what's going on in their minds. And that happens sometimes, but a lot of times like we want to be understood. right? Like a lot of time that we hate, like we want other people to understand our mental state. So a lot of what we might do is kind of like try to like behave in ways that makes our minds easier to understand. I think studying theory of mind from the perspective of mind sharing, it's as an analogy, it would be as incomplete as trying to understand language from the standpoint of the listener, right? Like if someone tried to come up with a framework of like language is just a listening problem, you'd be like, wait, you're missing like totally half the problem, and you're not gonna be able to solve it. The second claim is that once you switch to thinking about that, we really need to rethink like how we're building these models. I think to that, this kind of like idea of attributing mental states just doesn't work very well, and you need to have a fundamentally different kind of model. You need to model others' real-time processes, and I'll unfold a little bit what that means. Some of you that might have seen Marlene's poster on Friday might already start to get a sense. I think this is really a different way of starting to think about how we model it. So I'll clarify later, but the basic idea is kind of saying, okay, the basic view is this is what you're doing, right? So if you take it seriously, right now you say, okay, Julian's moving around and he's saying things, and now you know my beliefs and desires, right? Like you can tell that I believe certain things about theory of mind, and I believe that like I'm in a workshop where I just like get to say things, and I have a certain desire, right? Which is like, I literally told you my desire, like I want to convince you of two things. And so from that standpoint, like you're kind of done. Like you've done all the theory of mind, right? Like you know about beliefs and desires. And that doesn't feel right. Like it feels like right now you're doing so much more about my mind. So I think you're modeling kind of like all of these blue arrows. And that's like really like the main computational center of like what it means to reason about other mind, right? Like there's all of these things that happen in minds, like attention and processing and reasoning and recall. Like as I'm talking, whenever I pause, you can very quickly get a sense of like, did I pause because I'm trying to figure out like what's the right word, or did I pause to think? Or maybe I paused because I realized like I get excited talking and I start talking faster and faster. So eventually I need to like take a pause and slow down, right? And that also, it just feels free. Like you just watch and it almost feels like you can see it. So this is kind of like what I mean. What I'm going to do first though is I'm just kind of like walk you through how we got to believing this and becoming convinced that like we really need to rethink what we were doing. And this kind of started when we started with the very first projects of asking kind of like, well, we're able to infer mental states. Like that's theory of mind. You see someone walking around, but are we any good at it, right? In kind of like the more complex everyday world, it feels like sometimes we struggle. And to do that, like you can think of like representations following like a continuum. This is simplification. But on the one hand, you can think of like there's quantitative representations, right? So what I mean is like there's sometimes when you represent the world, you can have very, very precise representations. These usually happen in things like object tracking or motor control, right? If you think of like watching me like grab a water bottle, like that requires so much precision. I need to have like a very good representation of exactly what's the distance, how much pressure to apply, right? Like if I had kind of like a blurry picture, I would just kind of like knock down the bottle, right? So like that's the kind of thing where like you need a lot of very precise representations. Because this is usually kind of like associated with like very like low level basic features that you need to like walk around and just be like a functional creature. And then at the other end, you can kind of think of like, maybe it's like problems get computationally harder or maybe like less critical for our survival. You start to get to kind of qualitative representations. These are kind of like very commonly associated with high level cognition. So it's like the cases where like you can make the inference, but it's a little bit blurry, or like you get it roughly right, but it's not very precise. And so we started working on like, how do people infer beliefs and desires in these very, very basic events? So we're kind of like the very first layer of action understanding. So like the very first thing you need to do is you see agents moving around, you're trying to figure out like, what are they trying to accomplish and what do they know? And to the theory of mind feels very high level cognition. It feels like that's such a complicated activity. And kind of to my surprise, it ends up that the inferences fall a lot more on the quantitative end that you would expect. By the way, quantitative doesn't mean you have it exactly right. It means that there's many cases where you're going to have uncertainty, but that you're aware of exactly how much uncertainty you have, right? Like you're not always going to be able to entirely figure someone out, but if you have a suspicion of like how much they like something or what they think, you have like a quantitative representation of your uncertainty. So this kind of like, I was always puzzled by this. I was just like, it's kind of amazing that like we have like these very good representations. So the basic idea is here, right? Like if you're this agent in black and you're seeing another agent, you see them move around and you're trying to extract like, what are your hidden beliefs and desires? And we know both from our work and other people's work that you can make these very high resolution inferences about other people's mental states. So we thought, well, maybe here's why. Maybe the reason we're so good at this, and this is kind of a very basic layer, is because this is an evolutionary ancient problem. Like we're not the only ones that face this problem, right? Other creatures that don't have anything close to a human-like theory of mind, they need to do a lot of like body tracking, right? That's like even simple navigation was like, they require like tracking other bodies and like processing quickly. So I thought maybe this could be a specific thing about like seeing body movements, right? This is another problem. There's like new theory that even in vision, there's a new path. There's a third pathway that's different from dorsal and ventral stream, both functionally and anatomically, and it's specialized for social computation, right? So I would say like, we're good at this because it's just basically such an old problem. It's such a shared problem that it's kind of like built even into perception. So we said, okay, we have this problem. If this is true, let's change the signal to language, right? So now instead of seeing someone move around and you have to figure out the mental states, now you hear someone speak and you have to figure out the mental states. Surprisingly, theory of mind and language is a huge field, and we were kind of surprised that most of it focused on like how frequently do you do this, but there was very little work on like how good are you at doing this when you decide to do it. So if you think about it, language is just, it's a very different kind of problem, right? Like for most languages, you're getting them through a totally different sensory input, right? It's not visual, it's auditory. It's a very different kind of signal. It's not, it's kind of like three-dimensional data. It's kind of like linear data, and it's much more abstract. So you might expect that in this case, it would break down. And it turns out it doesn't. When you ask people to infer beliefs and desires from like basic referential expressions, basically basic utterances, people are just as good. You can recover it. And it's basically, it's like very quantitative representations. They're kind of shocking. So it seems that you can say, well, we seem to be just as good at inferring mental states, either from language or from observable action. And if you're in this field, you might say, yeah, that actually kind of makes sense because there seem to be some shared principles to how we do this. So a very common assumption when you analyze physical action is that you expect agents to kind of like move efficiently, right? So this is a classical study. If you see this little circle jumping behind the occluder, when you drop the occluder, even infants seem to expect like, oh, there must be an obstacle there, right? The idea is kind of like agents move efficiently. So if you're moving inefficiently, that's what allows me to infer that there was something there. If you go to language, there's kind of like an equivalent principle, which is speak as efficiently as possible. So that's why if I tell you, hey, can you pass me that ugly blue mug? You're immediately gonna get a sense like, oh, there's gonna be multiple mugs, and there's gonna be one that's uglier than the rest, and it's blue, right? So the idea is like, you can infer, in the same way that here you inferred an obstacle, here you can infer that there must be multiple objects, because otherwise, why would I say ugly blue? Otherwise, I would have just said, can you pass me the mug, right? If there was only one. Does this make sense? Cool. So you're like, in some sense, there's a clean story, but there's one problem. This is like probably the simplest experiment ever. You show people this and you ask them, what is this? And people tell you that's a red cup. And if you think about it, that's a little annoying piece, because it turns out that they're not being efficient in the simplest possible event. Like you just show one cup and people should say that's a cup. But they say that's a red cup. And they're using a color word like for seemingly no reason. And that actually like puts a pretty big problem with the whole framework, because on the one hand, I'm saying when you're listening to other people talk, you're extremely good at noticing whenever someone adds an extra word, you use that to kind of like really build like a very detailed picture of their mind by assuming that they're efficient. But then people are not communicating efficiently. So if this is true, we have a totally misaligned system, right? Like you have speakers that are just like using words for no reason. And then as listeners, we're like trying to build this whole picture in their mind. And we're like, oh, there must be multiple cups of different colors, where it's just not true. So we're kind of puzzling a little bit about this. And we realize is kind of like there's a really big thing missing in this experiment, which is the real world. Right? Like we don't live in these worlds where it's just like everything is in a vacuum and there's just like a floating single object, right? So if you think of a situation like this one, and there's only one cup, you can think like, what do you prefer, that I tell you, pass me the cup or pass me the red cup? Right? There's the cup in case any of you didn't find it. Right, so intuitively I can say, well, there's only one cup, so if I'm fully being kind of like efficient, I should just say the cup. But of course, that's going to be super annoying because there's so many objects, right? So kind of like intuitively, what's missing here is we're not just sensitive to like the information, we're modeling a mind. Like we might be realizing that if I say, can you pass me the cup? I'm putting a lot of work on you. Like you have to like basically look around and spend a while finding it. But if I tell you, can you pass me the red cup? I'm trying to help you out. So we thought, well, maybe what's happening here is like, this actually, it's not a failure. It's a very sophisticated form of social cognition, right? Like we're trying to do this, like when we're speaking, we're trying to like guide the other person's attention. So you can think of like language as kind of like instructions for how to like move other people's minds. And in this case, attention. So if that's true, you can make two very basic predictions. The first one is that the more objects you have, people should start using more color words redundantly. right? So if there's only one object, the color word is not that useful, but if you have like 16 objects, then like telling people what color the object is, that's going to be more helpful. Is that clear? Great. Here's the second prediction. If you speak a language like English, you should use more color words necessarily than if you speak a language like Spanish. I think German is, well, I'll get to this. I think German is phenomenal. The reason for that is because if you speak English, you say something like, pass me the red cup. So as you're speaking, you first tell people what is the color, and then you tell them what is the object. But if you speak Spanish, you would say vaso rojo, which kind of translates to like cup red. So when you're speaking, you're not allowed to reveal, like grammatically, you're not allowed to reveal the color until after you've mentioned the word. So that means that like, even if I want to be helpful and I want to tell you this is the color that you're looking for, I have to wait by first giving you the category, and then only later can I reveal the color. So by that time, like you've already been searching for the object a little bit. So let me show you what that looks like empirically. So here's a set of 4 objects. There's one triangle, right? So this is a case where if you're kind of like perfectly informationally, theoretically rational, you should just say that's a triangle. So if you ask English speakers, there's no tricky task. It's a task with 2 people, and you just have to pass the object, and you ask for this one. About a third of English speakers will say blue triangle, but virtually no Spanish speaker says blue triangle. They just tell you triangle. But now if you go up to 16 objects, again, there's only one triangle, so technically all you need to say is triangle. Now you get a bigger boost, like with both English and Spanish speakers start calling like blue triangle or triangle blue, right? So then we're like, okay, cool. But there's another puzzle here, which is a little bit weird. Like you might have gotten the sense that average speaking speed is about 400 milliseconds per word. And that's nothing. Like when I'm telling you this difference between like putting the color word before or after is a 400 millisecond difference. So it seems like we thought it was kind of extreme. They were just like, wait, like, is it really like that much of a difference when I'm trying to like guide your attention if I have to like wait 400 milliseconds before I can tell you the color or not? So like, does this actually like, it might be that like maybe speakers, we think we're doing something like very sophisticated, like, oh, I'm like guiding your attention very well, but ultimately actually doesn't matter. So to do that, we created this task where basically have like sets of 4 objects. We choose one object and we have a bunch of distractors. And then we just ask people, how likely are you to call this, for instance, the leather chair or the red chair? We use different expressions. We're not telling them anything about visual search. Like we're literally just asking like, would you call this a leather chair? And then people just tell you from 0 to 100, like how much they like the term. So now for every object and a set of other distractors, we have kind of like the rating for different expressions. And then we have a second task where we have people, they have the mouse in the center and they just need to click on an object, and they hear something like, click on the leather chair, and they go and they click on the object. So that means now for every object, we have 2 data points. We have one group of people that tell you like, yeah, I would call that a leather chair. And then we have how quickly can people click on that object when they hear that. And here's what the data looks like. So here each point is one of those expressions. On the x-axis is how much people say, yeah, I would use that expression. And on the y-axis is how quickly people can click on the object. So basically you get like a really nice negative correlation, which means that when people tell you like, oh yeah, I would call that object like the red chair or whatever, those are exactly the ones that when someone listens to them, they can like really quickly find the object and click on it. So it seems like speakers naturally prefer these expressions that are kind of like just better for guiding real-time attention. So we were around here and we're starting to think, well, okay, what kind of social representations do you need to achieve this, right? Like, how do we do this? And the key point, again, is just, if you think about these adjectives, they're not affecting the final mental state, right? Like in all these cases, you can just say the object without the color word, and ultimately the person is going to understand you eventually. So what matters is like how the person reaches the mental state. So that's kind of, we start to feel like these models where we're just trying to figure out like, ultimately, what's the belief or the desire? They don't make that different predictions that are that different. It's about like how quickly can you get the other person to have the right belief or the right desire, right? In this case, like the belief is like knowing what you want. So we started thinking, well, maybe this means that we're doing something like we're tracking real-time attention, right? So that's what I mean when I told you earlier, I think a lot of theory of mind is tracking all of these arrows. I mean, that kind of like the beliefs and desires are almost like the background, right? Like, again, when I started here, you very quickly got a sense that like, I share a lot of beliefs with you about like where we are right now and what we're doing. I told you what my desires are. And then once you have that, that becomes the background of the model. That's not like the key thing you're trying to infer, that's the grounding. And then on top of that, now you're trying to track all of these kind of like errors of like all of these moment-to-moment things that I'm using to interact with you and decide how to act and kind of like how to shape each other's minds. So the high-level idea of the model, what we did, it was say, let's try to have a computational model that now is like really trying to like track dynamic processes. So in this case, like the idea is like the model is now, when it's deciding how to speak, it's not trying to figure out like, am I being sufficiently informative? It's instead like rendering kind of like synthesizing like a model of a thinking mind, of like what a mind would act basically in real time. And it basically has this idea of like, as I'm speaking, the other mind is going to be like processing words. And it's not that I give you the full sentence and you process it, just as I give you every word, you're like processing each word one at a time. You're updating your beliefs. And from that, the mind is like trying to like control its attention and like move it around. I could talk about it later, but we did some experiments to kind of like get a sense of what the generative model looks like, right? But the basic idea is something like this. If you hear something like the metal chair, this is actually real life tracking data. Evaluator materials usually requires you to like foveate on the object. You need to just look at it. So if you hear something like the metal chair, you can see that like people start like looking, trying to figure out like, is this metal? Is this metal? And then when they hear chair, they're like, okay, it needs to be a metal chair. But if you say something like the green chair, people are a lot better at immediately moving in their eyes and looking at things of the right color. Right, so if you say green, you can see that happens. Red always just like pulls your attention like involuntarily. So you see the little involuntary pull. But that's the basic idea. So like the model is not trying to do like the classical mental state inference. It's trying to say, as I'm speaking, how do I chain words to get you to like efficiently move your attention until like I get you to like the right object? So we have a lot of cases where like all of them ultimately get you to the right spot, but some of them get you quicker. So I'm going to show you first some simulations of what this model looks like. So here's an event like the one I showed you in the experiment. So here on the x-axis is objects. These are simulated objects. And there's all cases where like you never need to use any additional words. There's one unique object, so you could just use that. As you can see, the model does start to look like to use redundant words. As you add more objects, the model is just like, oh, I want to add more color words. I want to use them to help you. There's a second effect that I hadn't told you about, which is if you control for the number of objects, in this case it's 9, if everything is different colors, people really like using color words, but if you make everything the same color, people stop using, they like using color words less, right? It makes sense. Like if you're in a very complicated room, you might say red cup, but if absolutely everything is red, you wouldn't say red cup, you would just say cup. And again, the model also, like as you start making everything monochrome, it's like, oh yeah, I'm liking color words less. And then we can do the same thing of manipulating whether the model can speak a language like English, where it can put adjectives before nouns, or like Spanish, where it has to put them after nouns. And here's a, right, so again, you get like, as you get more objects, it likes to use more color words, but whenever you force it to have a grammar like English, it's using them a little bit more, because it's realizing that like, you get the little, you're able to tell it immediately, so you get a little bit more help. So these are all simulations, but you're like, wait, all of these are actually known effects, like they're published. So we went and we just took the data from 4 papers. All of this data had been collected before we did any of this. And we just basically, we didn't try to fit the like parameters to any individual data set. This is a very nice way of just throwing model predictions against data sets, the data from 4 papers. As you can see, like it does a pretty nice job. So we're kind of excited about this. Just very quickly, I mentioned we've also done a bunch of like more parametric studies to test this. And basically you can see, yeah, I can talk about this later, but the model that's tracking mental processes just in general like does a much nicer job than like the more standard like mental state attribution models. I'll mention this. I don't know how much to get into this. Well, I'll just mention quickly, like in my mind, people sometimes interpret it just like, oh, it has to be one or the other. And I don't get why. I think there's, we've played around, there's mental state attribution models that sometimes like there's ways in which like you can play around with it and get them to capture some phenomena. And I think that's right. And I think it's just basically, it doesn't have to be like a unitary single solution in this case. Like we are inferring mental states and we're also tracking mental processes. Okay. So far, this is kind of like the first set of projects. We were just kind of like, yeah, it feels like, it felt like the mental state attribution models that they were starting to feel a little bit strained. And it felt like we need to do something, we need to rethink this a little bit. I'm going to tell you about a second case where we kind of like also reached the same conclusion coming from a different angle. This is from gesture. So it's came from, this is kind of like the classical stuff that we work with. This is the problem that we usually want to solve. So you see something like little agents and you're trying to like read like what's happening. What you're seeing there at the top right is actually like what our model is reading the behavior of this agent. So you can see it says it's chasing, and then it's kind of like, oh, it's looking for the other agent. And you know, you can do things like try to figure out like how complicated of a mind does this agent have. So I was pretty happy. I thought they were doing a pretty good job. And then Amanda came into my lab and was like, wait, but like these models, they always assume that agents are acting on the world. And that's like that's the basic assumption. Like all we do is basically when an agent is moving, you're trying to figure out like what part of the world is this agent trying to change. You're kind of like searching over the world and figure like where are you trying to get to? Like what are you trying to take? But so much of what we do is actually not acting on the world, right? A lot of it's communicative action. Like when I wave at you, I'm not trying to actually act on the world. It's like a very fundamental different kind of like inference that I'm trying to get in your mind, right? I'm trying to like reveal that I'm communicating. So the idea was also thinking, well, if it's all about attributing mental states, the problem is how do I move my body in a way that like ultimately you can conclude that I'm not trying to like grab an object and that I'm just trying to communicate with you. So it might be like, there's all sorts of like really weird movements that I could make that ultimately you'd be like, oh yeah, I guess like you're not acting on the world. So maybe you're communicating. But here again, we thought, well, it seems like this is a problem where we need very fast real-time communication. So it might not just be about like ultimately getting you to understand that I'm trying to communicate with you. It's about like, how do I get you to understand that very quickly, right? So it's kind of like, it might be that we want to not just reveal that we're communicating, I want you to like reveal as quickly as possible that I'm trying to communicate with you. So this idea is that like maybe gestures are kind of like shaped to very efficiently reveal that you're not acting on the world. So to get to what that means, we basically started with a very, you can basically take these models that we've developed, and you can say, okay, I have a model that's able to like uncover like what part of the world you're acting on, right? So if an agent is moving towards a bottle, you can say like, oh, you're gonna grab the bottle. So over that, you can basically try to optimize and figure out, well, what would be the movements that would like really confuse this model very quickly, right? Because if this model is assuming that everything you do is try to change the world, the actions that very quickly are just like, I can't make sense of it. Those are the ones that are revealing like you're not acting on the world, so you might be communicating. So I'm gonna show you first an example of a bad solution. So you imagine that this is an agent and there's a bunch of objects, right? And you might be like, are you going for an object? If you move like that, that's a terrible solution, because when the agent moves, you might be like, oh yeah, you're gonna grab a star. Oh no, I guess you're gonna grab one of those stars. And then eventually you're just like, oh, I guess you weren't grabbing any stars. But so it ultimately reveals that you were not trying to grab an object, but it just takes a while. But there's also good solutions, which technically fall under one category, but it's easier to think of them as being in two. So one of them I'm gonna be calling rarity. So the idea is like, if you're in a world like this one and you wanna show, I'm thinking about your mind and I wanna very quickly reveal that I'm not trying to change anything in the world. Something like this is a really good idea, just like moving quickly away. Like, what is the movement that most quickly reveals that you're not trying to act on the world, right? But that solution might not always be possible, right? Like, if you imagine that you're in a situation where, like, in any direction that you move, there's going to be an object, then the best thing to do is something like repetition. So the idea is like, you know, if you move in one direction, that's consistent with like one set of goals, but not the others. If I move in the other direction, that basically inverts it, right? So if you just like produce a movement a few times without changing anything else in the world, that can very quickly can reveal you're not trying to act on it. And when we looked at it, we were kind of like, yeah. And if you think about it, like when we nod, you kind of feel a need to repeat it. And again, when you wave, it feels like you want to repeat it. And when you do like thumbs up, it's kind of like a weird body position. So we're like, let's see if this is true. So what we did, and by we, I mean Amanda, was basically this massive effort of trying to collect gestures from like all over the world. So this included reading travel books, standing outside the Met before the pandemic and asking tourists like, hey, can you teach me like a new gesture? Going to like actual like also academic books and student associations. And we got 271 gestures from 34 different countries. These are a few visualizations. I wouldn't trust the country too much. It's a little bit tricky, right? Because you got people that will tell you like, this is definitely an American gesture. And then like it's just like, it's everywhere. So I wouldn't trust that entirely, but we have a 271 gestures. And then basically we did that. We just went through them and we coded like, to what extent are they producing some kind of like body movement that's quickly showing that you're not trying to act in the world, or are they repetitive? So here's what it looks like. Here, each square is a gesture. And basically it comes out. So almost 50% of the gestures are kind of like this kind of like rarity that I talked about. So for instance, this is a gesture that used in Mexico. It's a very polite form of saying thank you, right? And it's kind of like, it involves like putting your hand in a position that like, it's a very awkward position if you're trying to like grab objects or act on the world, right? It's kind of like revealing like, I'm not acting on the world. Almost the other 50% has some kind of repetition that kind of like reveals that you're not acting on the world. This gesture roughly means something like you're finished or something like that. And then of course there's a 10% that doesn't fall under like what we thought, but we still think it's finished. So there's of course like some repetitive gestures like that one, which could be seen as like you're just trying to scratch your nose or something, but it's a gesture. And there's also gestures like these that are technically like not rare, but people do consider them. And I think there's a lot of interesting stuff there that like we could talk about later. But the main point is, it seems like if you actually look out there in the world, gestures are they're designed to kind of like guide inferences to help you figure out quickly. And again, here you might ask, does this actually work? Like maybe we're thinking this, but ultimately for the observers, this doesn't matter. So what Amanda showed is like, this does help people detect communicative action. So what we did is we started with kind of point displays where you just see an agent moving around and you have to figure out like, is this agent communicating with you or not? And basically you get very nice effects. Like this is nice because we control very nicely for everything. And the movements that are like most quickly revealing that you're not acting on the world, people say like, yeah, that's communicative. Of course, you might feel kind of unhappy with these displays because you might say, well, yeah, this is very controlled, but like humans are not points moving around. So we did a whole other version of experiments now with actual like people moving around and body movements, and where we can kind of like norm them for amount of repetition and rarity. And the effects also come out. I think this paper literally has like 14 experiments once you add everything. So I'll just tell you about like my two favorite ones. Because a lot of these we were asking people explicitly, is this communicative or not? So like, well, can we get this in a kind of indirect way? So one idea was we showed people these videos and we don't tell them that they're gonna get asked to if the movement's communicative or not. They just watch it and we're like, do you think the person was alone or was there someone else in the room? And here you can find that if you show a basic kind of movement, people are just like, I guess you were alone. But if you add the features that we think make something communicative, they're like, oh, there was someone else there. And Amanda also replicated this and a bunch of other experiments among the Chimani, which are a farming foraging community in lowland Bolivia. So there's just like a nice like other data point to make sure that like we weren't just overreading like very culturally specific things from the US. I thought I was going to show you too, but anyway. So we know this helps you detect communicative action too. At this point, we were kind of also thinking, okay, this is cool, but it might be the product of like very slow cultural evolution. And if that's right, that goes against what I've been telling you. Like I'm trying to tell you, we have these real-time models of dynamic processes happening in other people's minds, and we're using them like very quickly to decide what to do. Right? But you might imagine that when people start gestures, like you just produce any movement, and the ones that are slow, they just feel kind of inefficient, so you stop using them. And just like through a lot of generations, they become kind of like optimized in some way to reveal that. I'm going to skip this part, but I'll just tell you that Amanda has shown that you can put people in entirely new tasks and you're like, come with a gesture now, and you can manipulate like the space of possible goals. And immediately people will come up with new gestures that like very quickly reveal that you're not acting on the world. So this comes up like immediately in one-shot tasks. How are we doing? Yeah, I have a little, okay, cool. So, okay, so I've shown you two cases so far. Hopefully, I've convinced you a little bit in both of these cases. It really seems that we need to go beyond thinking about just how do I attribute the right mental state, and it's more about like how do I like move your mind in real time to like get you to where we are. And again, I mentioned like when you think about it, that's a very different kind of representation. Like the classical models, when you're thinking about beliefs and desires, like a desire is basically something like a reward function over the world, right? It's just like assigning like numerical values to like states of the world. And beliefs are kind of like states, they're also representations of the world. But thinking about thinking, like thinking is not a state of the world and thinking is not a reward. Thinking is a computational process. So you really need to start thinking, or at least like we think we need to start thinking in terms of like, we need a new kind of representation. Like in theory of mind, what really matters is that you can represent computational processes. So it's kind of like these meta computational representations. And Marlene has been trying to like figure out like, okay, how can we actually think about this in like a very general framework that can help us like just get some traction on this. So I'm going to tell you at a very high level. Again, some of you saw this on Friday, but I just want to give you the intuition. I really like the idea is like you can think of like thinking as the first pass, like think of it as like a kind of like decision tree, right? So like you start and like there's usually like different thinking directions that you can take, and then when you go, you can keep thinking about it, right? So for simplicity, you can imagine it's something like chess. Right, chess is a very simple case where you can think like there's a space of moves that I can make, and then when I make a move, there's a space of responses. And so the idea is like when you instantiate a model of thinking, you might be thinking of something like this, like you're representing kind of like what is the space of like computational like traces that someone can have. So your intuition, imagine that you're in a situation where like you realize that like the other person is trying to accomplish a goal, and you can get it in like one thinking step. It's kind of like this obvious one-step thing. It might be something like you're playing chess and you make an error, and then it's just like, oh yeah, it's obvious now that like they can do a checkmate in one move. Like I just messed up. But then you see the other person just staring at the board, and they just like keep staring a long time. eventually you might start to get the intuition of being like, wait, is this person like even like looking at the board? Are they distracted? And the intuition here is that you've estimated that this should be done with very minimal computation, and you're gonna be like, no mind would ever take like 20 seconds to do this computation. So it must be that like you're not actually like doing computation over this. Now imagine that the solution is like something like 4 layers deep, and the person like looks at it and within like a second like makes a move. You might get the intuition of being like, oh wow, like you're really fast, you're a fast thinker at this, right? You kind of say like, okay, you went like 4 traces down, so I can estimate your thinking speed, and that was fast. But now what if actually the solution was like 20 steps down? Like it's just like this massive tree and the person sees it and in one move gives the right answer. At that point, you might be like, wait, there's no mind that could have a thinking speed that could travel like 20 layers down in that amount of time. So you get the intuition of being like, wait, you already knew the answer, didn't you? Okay, here's another case. Yeah. So imagine again, you go back to like one single, there's a very easy answer in one step, and you just see that person kind of like scratching their head and like staring at it, like totally puzzled for a while. At that point, you might kind of infer, well, maybe they went down the wrong thinking trace. So that's the intuition when you're just kind of like, I think you're missing something obvious, right? Like we all had that experience of being like, you're missing something. And that's kind of like the intuition. Yeah, I think you got the point. But the basic idea, I also mentioned quickly, like if you have like, for instance, 2 possible solutions to a problem, one's that like easy and one's that like very deep, depending on how quickly the person answers, you can get a sense of which solution they found, right? Like sometimes it can be possible to have like an obvious answer and a non-obvious answer. If someone's like me, like I got it, you're like, oh, you found the obvious one and not the another kind of like the nuanced one. And so what's kind of cool is like these feel to us like they're very common everyday inferences, right? Like this feels like that it gets closer to like social life and psychological reality. Like when you're talking to people and being like, oh, they just zoomed out. Like I was just, or like they just like, oh wow, like this person is just like such a fast thing. Like these feel like very real and everyday. And what's kind of cool is like within the same framework, you can kind of like get all of these things for free. So we've started to test these, and we did it in a kind of inspired by chess, but it's a simpler problem. It is called a rush hour puzzle. The basic idea is like there's this red car, and you need to get it out of the puzzle, and it goes out to here. And basically, every object can only move horizontally or vertically, right? So you can, if you start a little bit, you might be able to figure out how to solve this. Actually, I think I have a solution here. Well, I'll show you what the time the experiment looks like. And I just warn you, it looks like nothing. So, oh, actually already passed. Let me see if I can replay it. So I'm going to press. Where's my? So this is what trying the experiment looks like. Right. So in some sense, you can think of like it's the most minimal experiment ever. Like all you get to see is just like a puzzle, and there's like a pause of someone thinking, and eventually they're like, oh, I got it, and they solve it. And so the idea is that you can estimate based on this how much computation needs to be done here. And to do that, there's kind of like 2 ways that you do it, right? I show you that you have this tree of all decisions. What you need to do is figure out like, well, what is the goal that you're trying to get to? And you need to have like some expectation of like, how do minds navigate this tree, right? Because in terms of there's many algorithms for like navigating a decision tree. There might be something like breadth first or depth first. And so for that, yeah, I'm not going to talk about this either, but you can ask Marlene. With this kind of like an equivalent of the principle of rational action, which is the principle of rational mental effort, which is basically like agents are trying to do some kind of like smart estimate of like figuring out like which are the most likely nodes. I mean, if you know something like Monte Carlo tree search, it's not that, but it's a similar kind of like idea and spirit of thinking of like trying to like be smart about like what are the nodes that like you should guess. So basically, you can estimate. The computation is not the final answer. It's a sense of like what would be the possible thinking traces. So in this problem, the model is not just representing like the right answer, it's representing like what are the other possible moves that someone might have tried and been like, oh yeah, that doesn't work. And so far we have 3 experiments. And what we do is basically, and Marlene and our other colleagues, Abby and Ben, design a bunch of different puzzles. And then you can show for the exact same puzzle, you can just vary the length of the pause. Sometimes you show a very quick pause and the person gets it, or an intermediate one or a long one. And I'm just going to show you data for the first 3 experiments. So you can ask in this experiment, you can show the puzzle, and then you can ask how long did the person spend daydreaming, right? This is kind of like our proxy for distraction. You can see here's what the model system participants say. And it's just very nice. Like you can do a really good job of predicting people's intuition, being like, yeah, this person was super distracted or not. We can also ask the opposite side, right? Like we can ask, like, do you think that the person might have remembered part of the solution? Like how much of the puzzle did they already remember? Going from like, oh, they already knew the full answer. And then again, you can see that we do a really nice job. It's just the model works. And you can also ask like, do you think this is a really fast like puzzle solver or not? And that the same model basically does also a nice job of predicting it. So you can see, like, I think this is a very promising way of like starting to think of like a different kind of model theory of mind. And not just for like these kinds of events, right? Like I think these are the computations, again, that are very important for language and communication, right? Like, going back to when I mentioned, like, as I'm talking, whenever I pause, I think we get like these very rich intuitions if it's a pause, again, because I'm trying to like use a technical word or like forget I'm trying to think about that. And I think that's a very quick kind of like this process of estimating, well, based on what you're saying, it's like how much computation was required and how does it relate to the pause? Okay, so in the last, yeah, I think I technically have like 3 minutes. I'm gonna go like 5 minutes. Just gonna tell you stuff that I just think. So the problem is like all of that stuff on inferring beliefs and desires, that's become very well studied. So we have like really good pictures, or at least good theories. Even there's some competing theories of how this develops. But here we're trying to do something kind of different. And then there's still the question like, okay, so like, where does this come from? Like, how do we come to be able to like instantiate real-time models of other people's minds? And so the first thing I want to mention is I think the problem is like even more complicated the more you think about it. So I'm just going to start by pointing some, I don't know, things that I've been thinking about. So I first thing about it is like each of these arrows that we're representing, basically kind of like how beliefs like move internally or like how we change our own desires. Each of these things is incredibly complicated. They have like so much information that you think about. Just to give you one example, like as a belief, imagine that you overhear this conversation between Andrea and I at this day, and Andrea asks me, have you been to the Hafenhall? And I'm just like, I'm not sure, maybe. That should sound roughly fine. So you might be like, well, who knows? Like, it's a different city. Julian doesn't speak German. Like, we've just been doing things like, yeah, maybe. But what if Andrea asks me, have you been to Dubai? And I'm like, I'm not sure, maybe. Like, that immediately just feels like, what? Right, it's true, because like we have very good intuitions about memorability. Like we think, oh, in this context, it's reasonable for Julian to not remember this, but like you don't go to, at least like if you grew up in Mexico and live in the US, like you don't go to Dubai, and I was just like, I don't know if I've been, right? So in this case, just shows like we have like very rich intuitions about what's memorable to people. And it breaks down even further. Just in this case of memory, again, we have like very good intuition about like places that someone has visited, like what should be memorable. But also like conversations with a stranger, like if you think of conversations, like we have very quick intuition of being like, yeah, that's something that our mind would forget, or that's something that would like stick with the person, or an argument with a friend, or like the plot in a book, or a gift that someone received. And this even break down further down, right? If you just think of like remembering a gift that someone received, like my expectation if I give you something, my expectation that you'll remember it is going to depend what was the context, what I gave you, what was the reason that I gave it to you, like, and it just keeps breaking down. So even in this like tiny bit of piece, which is expectation about memory, it just keeps breaking down and down and down and down. And we just have like for almost anything, we have like these rich expectations being like, yeah, I know exactly like roughly how long until like someone starts forgetting this. I think it's the same about attention, about emotions, about a lot of things. So to me, the process has been like, how are we storing all of this knowledge and expectations? Like virtually anything I can think about, I have expectations about like how attention calling is going to be to you, how memorable, how you might emotionally react to it. So it's a lot. It's just a lot of information. And my guess is that the answer is that we don't store any of this knowledge. So here's the idea. If you think about the classical picture, beliefs and desires are so different across minds. And to be able to be a successful social agent, you really need to get that down, right? If I walked around thinking that whatever I like, you like, or if I think that whatever I know, you know, like I would just fail entirely. Like I wouldn't be able to get anything done, right? So it's very, very important that these need to be kind of like split and like very different representations. So there's some dimensions of minds that vary across people. But I think when you look at the arrows, these tend to be a lot more homogeneous across agents, right? In general, like you don't find there's differences, but they're not as salient as kind of like having like totally opposing desires. Like we tend to like not have expectation about people having totally opposing visual systems or like totally inverted memory systems, right? Because all of these arrows are basically kind of like the architecture of how minds work. And so those tend to be pretty stable. So the idea is like, maybe what we do is like, a lot of what we do in development as we're growing as social creatures is we're trying to learn what parts of our mind are actually predictive of other minds and which parts of our mind are not predictive of other minds. So you're trying to kind of figure out like eventually something like, well, all of my, I mean, actually, by the way, it might actually not be, I don't know why I put learned, but yeah, like basically, I think that's basically like one of the fundamental problems, and it might be partially, so kind of like core constraints, or it might be like learn from experience. But just to give you an example, and hopefully this isn't just me, there was a point in my lab where there was someone who was colorblind. I struggled so much it just felt like such an explicit cognitive activity, right? And it's interesting, like someone told me like, I'm vegetarian, I like this other things, like they tell me different desires, I can just immediately incorporate them. And I'm like, I can reason about you very fluently. But when someone told me I confuse these two colors, I couldn't be like immediately, like it's incorporating to my mind, I can do it. It just kind of felt every time I had to think, I was like, wait, are these two? So kind of like, I just wasn't good at like changing those parameters in my model. So it is like over time, you start to learn like what aspects of your mind just basically are stable, right? Like things like visual salience. If I find something very visually salient, there's a good bet that everyone's going to find it visually salient, right? And we do that. Like if I see something amazing, I can just say, wow. And even though I didn't say what I talk about, like if you turned around and like you would find something, you'd immediately know like what was the thing that I was wowing at. And it's just an assumption that our minds are similar. But it's not a simple process. I don't think it's just basically like a black and white being like, oh, this part of my mind means like it's just identical to everyone and this part is not. I think we learn basically some transformation problems where you're trying to like figure out like some correction mechanism, being like, I know how my mind works and I'm going to apply some transformation to get some intuition about how another mind works, right? So if we have experience in memory of like how memory works, but you can also realize you're like, oh, I'm a little bit more forgetful. So if you forget something, you can still apply the correction mechanism, be like, because I know I'm forgetful, I need to like increase a little bit the memorability for other agents. But I actually think this thing is not just about like mental processes, about all mental states. So to give you an example of like how these correction mechanisms work and that they're not simple, I don't know if this is true, but it's a thought experiment. I think if any of you went outside and like took a pile of dirt and tried to eat it, I think you would all have a bad experience. But in terms of social cognition, you would immediately get a strong intuition that you just had a universal experience, that you'd be like, this was terrible. And I think like any human that did this would also agree, like, at least on the first one, they'd be like, this is terrible. If you try to spicy chocolate, I think some of you might also have like a very negative experience. You might be like, this is terrible. And some of you might have a very positive experience. You'd be like, oh, this is great. But you're also, in that case, you're gonna know that you just had a non-universal experience. Like in this case, you're not gonna, if you didn't like it, you're not gonna have the same reaction being like, and everyone would agree. You actually can get an intuition that being like, yeah, I can tell that I'm in the minority, or I can tell like I'm in the majority. Or I think people that try to be like, you can estimate like roughly how many people were kind of agree with you. So with that on, like I think the right way to think about this is something like, again, you have these two agents, and then you have the standard thing, you have an abstract theory of mind. So you see another agent, you're trying to pull out their beliefs and desires. We also have a theory of how our own mind works, right? Like we start learning about our own minds. And then a really critical part, I don't know what to call it, so I'm calling it right now a metamentalistic theory. But you learn kind of like a metamentalistic theory of like how your own mind resembles and is different from the minds of others. And I think these links are part of like what really gives you the ability to like very rapid real-time like expectations about like how other minds work in real time. It gives you that ability. So with that, I'll just end. Thank you to all of you, and thank you to my lab.
We have time for some questions.
Hey.
Hi. So in one of your earlier studies, so the one that's like red up.
Yeah.
I was just wondering how you disambiguate this from another account, which might in fact be, just kind of an inflection of the way you interpret it. But I would call this a red cup because it's relative to my prototype of the category cup. It's kind of on the margins. So if this was a ceramic cup with a normal mug, the off-white, I probably wouldn't say it's a white cup. I would probably say
good.
So,
yeah.
So I mean, it's also like the internal search rather than just what's in the external environment.
Yeah, that's right. That is true to some extent. We know it's not entirely the case. So there's kind of like two common concerns. One of them is like you're just naming the prototype. Another related concern, which you didn't mention, is it might be an accessibility thing. So you can think of like there's fewer color words and there's more object categories. So retrieving an object category is slower. So like you just like you're using the words to like buy yourself some time. I mentioned this other one because I think they both get solved by the same problem. That's the same solution. So what you said is true. Like you definitely get those effects. I'll also mention it's kind of cool as listeners, we discount those. So if you know that it's like kind of like a common construction, like you don't take the extra words to like reveal anything about mental states. But what we do know is that that's why we have experiments where they have exactly the same object and you can manipulate what people will call it. So for instance, actually think, yeah, what do you think of this one? Like, in this case, if it's all just about the prototype, you shouldn't get the effect as you increase more distractors, people start using that color word more. Or that as you make everything monochrome, people start using the color word less.
With the English, Spanish, it doesn't make much sense why there would be a difference if it's the prototype effect. But for the complexity of the array, I mean, I think if something is off prototype, I think it is hard to find when there's more objects, just because you're kind of expecting certain things, and if it's like deviant from, I can't really explain it, but for me, like it's not that incongruent with the prototype account. Although the English,
yeah, no, I don't think it's incongruent. Like what I'm saying is, well, it depends on what you mean by incongruent. Like I think they're prototype accounts. Let me put it this way. I don't think you can build a prototype account that will be able to like get all of the effects of like the increasing, the decrease in monochrome, the language switch, and plus I didn't talk too much about this experiment, but we have like a one where it's like real objects and we're asking for ratings, explicit ratings for everything. If it is true, like that would be awesome. Like, because that actually, like, let's assume that's true and it's all about prototype. Then I think the burden is kind of explaining why is there such a coincidence that like the things that the prototypical name actually is the one that also optimizes for visual search, right? I show a little bit that data. Like we know that expressions people like are the ones that like are really fast for visual search. So I actually think it would be cool. Like I think then I would want to know what, yeah, well, why is it that the prototype name is like also optimized for search? But yeah.
It's an interesting question. Yeah.
Hey. Yeah.
Thanks for start. So yeah, I guess I mean I find this all like really compelling, but something I'm just wondering is like going back to like Marlene's work on like how people think about thinking. I'm just wondering like maybe I didn't catch this, but like when you measure like how or assess how people you know kind of come up with explanations for or like infer explanations for why people are or sorry what people are thinking based on their actions. So you say, for example, like cases like chess where people make like move and or like some kind of game where it's like kind of incoherent. Like if you don't ask people, and I don't remember if you ask people like how much was this person daydreaming or something, like if it's spontaneous, do you get less homogeneous responses in terms of like, you know, some people having the intuition that no, it's not just because they're distracted or it's some other reason. I guess also like the example of like Dubai, like I don't know, maybe this is just me, like when you if you had it like showed us the other example, right, and it was just like spontaneously just showing us that example, like oh I don't remember if I've been to Dubai, like maybe it's like you know some people like you get less homogeneous responses because spontaneously some people are just like well maybe you flew through Dubai and like you just didn't know or something like that. I don't know.
Yeah, totally. I mean, I think that's really interesting. I mean, I would need to think about this. My immediate reaction, I'm also curious to hear what Marlene thinks. Is yeah, well, yeah, okay. So there's definitely going to be some variability. I think the question is like, is it variability in how frequently we're deploying theory of mind, or is it a difference in like the other kind of dimension? Marlene has some unpublished data that I don't know. Like I think, I don't know. Do you want to talk about like the?
Sure.
Data you have?
So I'll use the thinking versus daydreaming example. So like maybe if you're a particularly fast thinker, your priors over how quickly people might think could be like particularly fast as well. So for you, like if someone pauses for a long time, you might be more likely to say that they were daydreaming for a long time versus someone else might instead have said, that's a possible amount of time to be thinking. I think they're just a little bit slow. So I think that there are definitely individual differences in the theory of mind judgments that we would make about another person, and perhaps those are also based on how our own mind works and the individual differences in our own thinking.
But, sorry, so when you like, did you ask them explicitly like, how much do you think this person is daydreaming?
Yeah.
Like, had you just asked like an explanation of what they were thinking? Would they spontaneously? Like, you didn't constrain the space of like what they were thinking. Like, would they spontaneously have like kind of generated homogeneously like kind of that response? I don't know.
I agree with you. I think that's an empirical question, but yeah, we've thought about like, I mean, the problem is like the space of mental state explanations is massive. So like, I think ultimately we want to go there. We've talked a little bit about like doing some open-ended studies, particularly with like chess players, where like it might be like depending on the pause. Chess is just like a convenient example because you have scores, and like if you know other people's scores, like that changes like your amount of confidence. So like yeah, we've thought about like doing some open-ended as with like chess players, like varying their skill and seeing like how they analyze another person's pass. Yeah, hopefully we can give you an answer in like a year or two. Anya?
Yeah, I was gonna say, I think it would be interesting, so that example of the game you made up, the inferences people would make if you had someone, instead of just the game itself, but like the person playing it was an expert playing that game versus a novice playing that game, the inferences you make about how much that person was thinking. So if someone that's never played the game before was really fast at it, I think the inferences would make there would be different than an expert at that block game.
Yeah. I bet that could be modeled like I mentioned, like mine has like a sense of like some rationality estimates of like when the mind is thinking, it's trying to decide like which are the traces that are most promising. And I want to be surprised, like maybe our expectations about those change depending on like your believed expertise of the player.
I think expertise could also affect like the depth at which someone could plan. Like someone who's an expert might think faster and also be able to plan more moves ahead. And then that would affect.
Yeah, that would be a cool thing to do.